Welcome to another physics class. In our last lesson, we started the topic inertia, and by then we defined inertia as the resistance of an object to change its motion. That is, inertia is the resistance of an object to change its motion. And by the time we finish on that day, I promised that in our next class, we are going to inertial mass. So for you to understand the topic better, please first go and watch our last video on inertia, so you can come back and watch today's video. If you are not subscribed, please try to subscribe, like and share, so when I upload a new video like this, you'll be able to get the notification in time. Now today, as I said, inertial mass is simply means the properties of an object which describe how difficult the object is to change the motion. Take it again, inertial mass, it describes the properties of an object which show the difficulties for that object to change its motion. Let's write inertial mass is the property of an object which describe how difficult it is to change its motion. In another word, inertial mass is the ratio of force applied to an object, ratio of force applied to an object to acceleration of the object. That is, inertial mass is equal to force over acceleration. That is, the force applied to that object to the rate of change in velocity of that object, which is acceleration. That's the inertial mass. That is, M is equal to F over A, as on the board, where M is equal to inertial mass, F is force applied, and A is the acceleration. From this equation on the board, we can now say that inertial mass is, for a given force, inertial mass is inversely proportional to acceleration. According to this equation, mass is directly proportional to force, where the inertial mass is inversely proportional to acceleration. Now, to explain further from the equation, we can now say that larger inertial mass we experience smaller acceleration. At the same time, smaller inertial mass we experience larger acceleration. That is, according to the equation, the more massive an object is, then the acceleration produced will be small. And the smaller an object is, then the greater acceleration it will produce. To illustrate these two statements on the board, that is, larger inertial mass will experience smaller acceleration, and smaller inertial mass will experience larger acceleration. From the screen, you can now see from the three figures on the screen, that is, the man pushing the wheelbarrow, the second one, the man pushing the car, and the last one, the man pushing the elephant. You can now see that, according to the two statements now, the one with the largest inertial mass is that man pushing the elephant, and that one will now have the smallest acceleration, followed by the man pushing a car, and followed by the man pushing that wheelbarrow. It means from the statement, the man pushing the wheelbarrow will have the largest acceleration because it has smaller inertial mass. To use another illustration to explain these two statements, let's look at what we have on the screen again. That is, the first man pushing a wheelbarrow, the second man pushing a car. Then from the diagram, you can now see that the man pushing a car also will have larger inertial mass, and it will have smaller acceleration. And the man pushing wheelbarrow will have smaller inertial mass, therefore it will have the larger acceleration. This is the case of this car and the truck on the screen as another illustration to explain the two statements. You can now see that the car and the truck are driving with the same force. I think the driving force is given there, that is 5 Newton for each. But the fact that the truck will have larger inertial mass than the car, so the truck will have smaller acceleration, while the car will have the larger acceleration because it will have smaller inertial mass. I think with the three illustrations now, we should be able to understand what meant by inertial mass compared with acceleration. Now, let's look at differences between inertial mass and gravitational mass, or you call it weight. Don't forget, in one of our lessons, we came across gravitational mass or weight, and we discussed lessons on it. So we only need to differentiate between the two terms now, that is the inertial mass and gravitational mass. Now let's take it one after the other. From the definition, inertial mass, as we said, is ratio of force to acceleration. Ratio of force applied to acceleration. Why? Gravitational mass is a force of gravity on an object. Force of gravity on an object. or you call it gravitational pull on an object. That's the first difference. Number two, the inertial mass is constant everywhere. Constant everywhere. While on the other hand, gravitational mass or weight, since it is force, it varies from place to place because it's a force. Number three, inertial mass is a scalar quantity. Why? Gravitational mass or weight, once it's a force, is a vector quantity. Don't forget, in one of our lessons, we discuss and give example of scalar and vector quantity. Number four, the unit. Unit is kilogram. While for gravitational mass or weight, the unit is Newton. Number five, dimension of inertial mass is capital M, while dimension of gravitational mass or weight, since it is force, the dimension is L t raised to power -2. Are the possible differences between the two quantities. Then we can now talk about the similarity between them. Similarity between inertial mass and gravitational mass. The similarity between them is that both are derived quantity. Both are derived quantities. That is, gravitational weight is a derived quantity. Gravitational mass is a derived quantity. Inertial mass is a derived quantity. Once we say inertial mass is force over mass, so it's a derived quantity. That's the similarity between them. Now the next thing is measurement and formulas of inertial mass. What does this one mean is that how can we measure inertial mass and the correct formula that we can derive from such measurement. The first one we are going to look at, we can measure inertial mass by the use of trolling vehicle, and set of weight. Call it force. As shown on the screen, when you look at the trolling vehicle and that set of weight that will move that trolling vehicle. So when the set of weight is increased, definitely the trolling vehicle will accelerate. And from that one, that is where we got our formula that inertial mass F is equal to F over A. That is, the F represents the weight added for that rolling vehicle to accelerate. Then we consider the acceleration of the rolling vehicle. So from that experiment, we have this formula as shown on the screen. Number 2, we can also use a loaded spiral spring or spring balance to measure inertial mass. And from the screen again, when you look at that screen, it shows a loaded spiral spring. And if you don't forget, it's why with us under this platform, we discuss lengthily on how to use this spiral spring when we are dealing with simple harmonic motion. So by then, we arrive at, when we are using a loaded spiral spring, we arrive at angular frequency is equal to square root of K over M. That is the angular frequency, or we call it frequency of oscillation. That is the omega is equal to root of K over M, where this our M is that the inertial mass that we are looking at. So making M the subject of the formula now, we are going to have frequency of oscillation square or angular frequency is equal to K over M. And from there now you can now see omega square M is equal to K. So we are going to have our inertial mass M as equal to K over omega square. As I said, where M is equal to inertial mass that we want to determine. Then K is the force constant of the spiral spring, the force constant, or you call it elastic constant. Then where this omega is the oscillating frequency. So from there now we can also determine or measure the inertial mass by using this spiral spring, and we got this formula. Don't forget, when we are dealing with simple harmonic motion, we talk lengthily on how to use this spiral spring, and we arrive at this formula by then. So for you to understand this better, please try as much as possible to go and watch our series of videos uploaded on simple harmonic motion, especially under simple harmonic motion of a spiral spring. The period of oscillation, that is the capital T of that loaded spiral spring, to determine our inertial mass also. That is according to what we have on the screen. So the inertial mass also can be the measure and arrive at the formula on the screen. Let's look at examples under inertial mass. The first example, as shown on the board, 3 objects are used by physics teacher to demonstrate the concept of inertial mass. He applied the same force to each of the 3 objects and noted that object A accelerates at 1.5 meters per second square, object B accelerates at 0.7 meters per second square, and object C accelerates at 2.0 meters per second square. Now, which object has the largest inertial mass? Solution to this one. The first thing, don't forget our definition of inertial mass as inertial mass is equal to force over acceleration. If this is the case, for the object, first object accelerates at 1.5 meter per second square, 0.7 meter per second square, 2.0 meter per second square. The force is constant, that is, m is directly proportional to force. Now, let's now compare this one with the acceleration now. The object with the largest inertial mass, according to this formula, we have the least acceleration. Therefore, object B will have the largest inertial mass. Why? Because it has the least or the smallest acceleration as 0.7 meter per second square. So from the formula, you can quickly arrive at the correct answer from that statement. That's the solution. Now let's take this one as example 2. What will be the inertial mass of a body if its acceleration is 2 meters per second square on applying a force of 12 Newton? Solution to this one. Now, don't forget our formula for inertial mass. N is equal to F over A. And from this question, F is given as 12. Then A, according to the question, is given as 2. So without wasting time, the inertial mass M will be equal to 6 kg. Let's take this one as example 3. A loaded spiral spring of force constant 50 Newton per meter oscillates with an angular frequency of 0.2 Hertz. What is the inertial mass of the spring? Now, from this question, solution. What are the parameters given? Force constant K is given as 50 Newton per meter. Then, angular frequency, that is omega, is given as 0.2 Hertz. Then we now have to calculate inertial mass. And don't forget, from a loaded spiral spring, as we derived the other time, inertial mass M will be equal to omega square K. Now, and our omega is given as 0.2. So this one will now give a 0.2 square multiplied by 50. So this one will now give 0.04 multiplied by 50. And the answer to this one will now give us M equal to 2 kg. Now, this is the convenient point to stop on the inertial mass. Don't forget, we started the topic from inertia, and today we treated inertial mass. So, and as I said, we are going to stop on this example 3. In our next video, we are going to Newton's laws of motion. As I always say, if you are just joining us for today, please don't forget to like, share, and subscribe. So when I upload a new video like this, you will be able to get the notification in time. Thank you.